All right. So we're working with gears in this project, and I just wanted you guys to know to have some knowledge about how gears work and the different things that you can do to them to use them in your project and leverage them in your design. So the design that we're using for the wings is a 1-to-1 gear ratio. So what that means is basically that like they're the same gears, right? So let me explain this first. So if I go to move this gear, um, as this one rotates, the other one will rotate in the opposite direction. So we're using this idea to make it so that we can have the wings move in the same direction we can have two wings moving in the same pattern or direction by only using one motor. So if we draw it out, as this guy rotates, that means, so if this is red, right? The right one's red and the left one's green. Then as this one rotates and pushes these teeth, this guy is going to want to rotate this way. So when that guy rotates this way, this gear is going to come upwards. So if there's a wing here, this wing is going to come upwards. Well, what happens to the right gear? So as it comes down this way, it goes this way. So that means this wing is also going to come upwards. And the same is true if you do the opposite, right? So if this gear is rotating this way, that means by the time it gets to here, that's going to make the green gear want to rotate this way. So then once it gets over here, that means it's rotating down. This wing is rotating down. And this wing is also rotating down. So we have two gears that are basically moving in unison with one another. Now, if we attach one more gear, which is what we're going to do in the design, if we attach one more gear and it's meshing with this, and we put a motor behind this one, then we can use this one to control the red one. So if this guy's rotating this way, then this guy rotates this way. And since it's meshing with the green gear, this guy is going to rotate this way. So just by using one motor and a gear train, we can make multiple things happen. We can have two wings moving with only one motor. Now, let me explain something else that is also powerful with gear trains. This is with using only two gears that are the same size. What happens if the gears are different sizes, but the teeth are still meshing? So what if I double the set of teeth? So this guy's going to be twice as big, right? Okay. So because we didn't have motors attached to these two gears previously, they were idle gears. But if we're attaching a motor behind it, they're called drive gears. So what happens now if I go to rotate this one? What happens to the other one? So let's say this motor that I'm rotating, this blue one on the left, is the drive one. So now the motor is doing the same thing, right? It's still rotating at the same speed. But because we have a bigger gear attached to it, for every one complete revolution of the drive gear, the left gear, the right gear is going to rotate twice, right? So if it's rotating twice for every time the left gear moves once, that means that the right gear is moving twice as fast. So that's a rule now. So if we increase the size, if we double the size of the drive gear, and we have a 1-to-2 ratio, and the second gear is half as small, it's going to rotate twice as fast. So we can use that to our advantage if we ever are designing something that is moving, we want it to move faster, And the opposite is true, right? So say we want the right one to be the drive gear. So now, as this one's rotating, this one has to rotate 2 times to get one rotation out of the left gear. If the right gear, if the right blue gear is the drive gear. So what's the advantage of that? Now, whatever we attach to the right gear, the left gear is going to move half as slow. But the advantage of that is that the right gear is going to be easier to rotate. So we'll get higher torque. We'll be able to do more work with higher torque because we have a now 2-to-1 gear ratio. The drive gear is rotating twice as fast as the idle gear that we're connected to. So we can use that to our advantage based on what we want to accomplish in our design. If we want something faster, you make the drive gear bigger. If you want the result to be faster, you make the drive gear bigger. If you want more strength, you want higher torque, you make the drive gear smaller. So the motor has to do less work to do a revolution. We're not going to use different size gears for this design, but that's a concept I wanted to explain to you because this is super useful, and you could 3D print gears all the time. I 3D print these gears in solid plastic, and they're super strong, and I'm using them for a bunch of different projects. But this is a super powerful tool to use in your designs to accomplish whatever you want. So just wanted to explain that to you guys, a little tidbit to make sure you really have the full grasp of knowledge of what we're designing and how you can leverage this to use this in your own designs. See you in the next part.